Today we are going to discuss recursive rules for sequences. So recursive rules gives the beginning term and uses an equation relating the answer to the previous term, okay? So recursive rules can be arithmetic, geometric, or neither. The key though is you are using the previous term for these recursive rules, okay? So an example, we're going to label the parts like what these represent. So a sub 1, remember, represents the first term of a sequence, okay? A sub n is the term that you want. So the current term, we'll say. A sub n minus 1 represents the term before this term, or like the previous term, okay? So the term before slash the previous term. So if I say a sub 4, I'm going to put a sub 3 here because 4 minus 1 is 3. Okay? And then this plus 4, it represents the pattern of the sequence. Okay? As you guys can see, this one's arithmetic because we're adding. Okay? So if you're adding or subtracting, it's arithmetic, geometric, you're multiplying or dividing, remember. Okay, so let's write the first 4 terms of each of these sequences using the information that we're given. So the first term here is 2, that's a sub 1, and we still need to fill in the next 3 terms, okay? So I'm gonna, this recursive rule is telling me, hey, take the previous term and subtract it by 3. So 2 minus 3, if you're not sure, use your calculator, is negative 1, okay? To get the next term, I'm going to subtract 3 again. To get the next term, I'm going to do that, subtract 3 again. So 2, negative 1, negative 4, negative 7. Okay? All right, number 2, a sub 0 equals 1, and our recursive rule says, hey, we're going to take the previous term and multiply it by negative 3. So I'm starting at 1. We just want the first 4 terms. This is the first term of that sequence. So I need to find the next 3. So this rule is saying take the previous term and multiply it by negative 3. So 1 times negative 3 is negative 3. Multiply that by negative 3 and you get 9. Multiply that by negative 3 and you get negative 27. Okay? It's as simple as that. All right, number 3. Our first term is 3. To find the next 3 terms, because we need the total of the 4, we're going to take the previous term, square it, and add 1. Okay? So this previous term is 3. So I'm going to do 3 squared plus 1 to get that term. So here, there we go. 3 squared plus 1 is 10. Okay? So now to get the third term, I'm going to do 10, because that's the previous term, square it, and add 1. So 10 squared plus 1, 101. And then now I'm going to take the previous term, which was 101, square it, and add 1. I'm just plugging it into the little formula. 10,202. And that's it. Okay? All right. Now, I'm going to give you a sequence, and you guys have to give me the recursive rule. So, we need to figure out if like this is arithmetic or geometric, like kind of like what my common difference or common ratio is. So to go from 21 to 17, it looks like I'm going to subtract 4. 17 to 13 is minus 4. 13 minus 4 is 9. 9 minus 4 is 5. So this is arithmetic. So my a sub 1 is 21. That's the first part. You need both of these to write a recursive rule, okay? So that's my first part. And then, let's see here. A sub n is the previous term. So a sub n minus 1 minus 4. We're subtracting 4 from each previous term. And that's it. That's all you need. Okay? Number 5. Let's see. How do we go from 2 to 6 to 18 to 54 to 62? Looks like we're going to have to multiply by something. Maybe 3. 18 times 3, is that 54? Yep. 54 times 3, is that 162? It sure is. So a sub 1 is 2. So this is geometric, right? So this is saying, hey, we're going to take 3 and multiply it by the previous term, which is a sub n minus 1. All right, number 6. Let's see here. Looks like we're multiplying by 2. No, we're not multiplying. We're multiplying by half. Because 1 over 2 times 1 over 2 is 1/4. Yep. Times 1 over 2 is 1/8. Times 1 over 2 is 1/16. Yep. So my a sub 1 is a half here. And then my recursive rule is we are multiplying the previous term, so a sub n minus 1, by a half each time. So that's what we multiplied each of those by. Okay? That is how you do recursive rules. Now, we are going to write both a recursive rule and an explicit rule for each. So, the explicit rules are the arithmetic and geometric sequence formulas, okay? So let's start with, well, let's first see, do we need to get a sequence going here? Oh no, we don't need a sequence. Okay, so we're given D, which means that this is arithmetic. So we are going to be using this formula for the explicit. But let's just start with the recursive. So a sub 1 is 3. And a sub n, this is saying, hey, we're going to take the previous term, so a sub n minus 1, and add 10 to each number. So this is the recursive rule. Okay. Now for the explicit, because this is arithmetic, we're going to use this formula. So a sub n, and you don't need to know what you don't have to clarify what a sub 1 is here, because remember, the explicit formula just gives you the formula for any term number. So a sub 1 though is 3 plus the d value is 10 and minus 1. So I'm just going to go ahead and simplify that by distributing the 10. So a sub n equals 3 plus 10n minus 10. So a sub n is 10n, 3 minus 10 is negative 7. So this is the formula for the explicit rule. Okay. All right, number 8, we have a sub 1 is 1/2, r is 4. So this tells me it's geometric because it gives us an r value. It's good to know your vocab. D is common difference, arithmetic. R is common ratio, it's geometric. So let's write the recursive rule first. We've got a sub 1 is 1/2. And a sub n, this is saying we're going to multiply each previous term by 4. That's it. That's your recursive. All right. And then this is the explicit formula for a geometric sequence. So we're going to do, oh, sorry, I'm trying to get like a good, there we go. So a sub n equals a sub 1, which is 1/2. R is 4 to the n minus 1 power. There's nothing to simplify there. Because remember, you cannot multiply these because this is being raised to a power, so this is the explicit. Make sure you guys are labeling which one's the explicit and the recursive, because that does matter, okay? And then I think that's it. Let me check. Yep, that's all. All right. That's it.